Hello, fellow students. Today we are going to continue with the second exercise related to graphs. So stick around and enjoy yourselves. Okay, so the first question is that given the graph in the picture, this graph that we can see here with 6 nodes and several links, they ask to write the adjacency matrix of such a graph. Right, okay, so we remember from last lesson that the adjacency matrix just counts the number of links that are related to a node, right? So we start in order, right? So for instance, in the first row of the matrix, we can count the number of links coming out of the first node. In the first position, the links that exist between 1 and 1, right? As we don't have any loop, it could be 0. In the second position, the links that go from 1 to 2. And in this case, it's A, right? We only have this link from 1 to 2. So we write 1. On the third position of the first row, we have the number of links from 1 to 3. And in this case is 2. Right, as you can see here, we have 2 links from 1 to 3. On the fourth position, we have the links from 1 to 4. In this case, we have 0 links from 1 to 4. In the fifth position, we have the links from 1 to 5. And we have 1 link, which is B. It's called B, from 1 to 5. And finally, in the last position on the first row, we have the links from 1 to 6, right? And we don't have any direct link from 1 to 6. So this is 0. Once that we have finished, we have reviewed all nodes, we pass to the second row. And in the second row, we will count the links coming out from the node 2. So we have 1 link from 2 to 1. We don't have loops on 2, so number is 0. We have 0 links to 3. And we have 2 links to 4, right? If we check it out, as you can see, 3 and 2 are not directly connected, but 2 is connected to 4 with 2 links, H and key. Right, so that's why we put a 2 here. Then we have the number of links from 2 to 5, which is 0, and the number of links from 2 to 6, which is 1. Well, we pass to the third row, and we have the number of links from 3 to 1, which is 2. The number of links from 3 to 2, which is 0. Number of links from 3 to 3, which is 0. Number of links from 3 to 4, which is 2. Number of links from 3 to 5, which is 1. and number of links from 3 to 6, which is 0. We pass to the next row, which corresponds with 4, and we have the number of links from 4 to 1, which is 0, number of links from 4 to 2, which is 2, number of links from 4 to 3, which is another 2, number of links from 4 to 4, which is 0, number of links from 4 to 5, which is 1, and number of links from 4 to 6, which is 0. We pass to 5, to the fifth row, and we have number of links from 5 to 1, which is 1, number of links from 5 to 2, which is 0, from 5 to 2, no, wait, we have 1, right? We have, it's a bit hidden here, but the link C joins 5 and 2, right? So we got 1 here. Then we have the number of links from 5 to 3, which is 1, the number of links from 5 to 4, which is 1, from 5 to 5 we don't have loops, so it's 0, and for 5 to 6, from 5 to 6 we have 0 links. And finally we go to 6, right? If you check this node, 6, we only have 1 link, right? We only have 1 link. So we will have all zeros in the matrix except in the second position, which will be 1, because of the relation between 6 and 2, right? And zeros in all the rest of the matrix. So this is the adjacency matrix of this graph. Just let me move this a bit. Of the graph G. Okay, and now the second question is this one, right? Which is we consider a subgraph of this one, right? Which consists only on 3 nodes and 3 links, right? So remember that this is the definition of a graph. In this definition, we declare first the set of nodes, then the set of links, and then the application, right? Which is P subgroup in this case. And this application is the same application that we had here, but restricted to these three links. So they ask to draw the directed version of this graph, right? So let's start drawing G subgroup, which is we draw the 3 vertices that we have that are 1. Okay, this doesn't look very good, right? So let's do it again. We have these 3 vertices, 1, 2, and 3. And then we have 3 links but being the application the same as before, these three links will join the same nodes. Right, so we have A, that is between 1 and 2. We have F between 1 and 3. And then we have I also between 1 and 3, right? Let's write the names A, F, and I. Okay, and now they are asking for the directed version of this graph. Right, in the directed version, we have the same nodes. 1, 2, 3. And we split every link in 2 links, right? One in one direction and another one in the other direction. We can call them A1 and A2. And here we do the same. We can split F in 2 links, and we get F1 and F2, and we can split I in 2 links, right? And we get I1 and I2. Okay, so this is the second problem. Just take into account that to write the adjacency matrix of a graph, we count the links that we have between the nodes. And the node that we count on is determined by the row of the matrix, right? So here we have the number of all the links between the first node, which is on this column, right? This is, okay, we'll write it green. And this will count the relations with the rest of the nodes, right? From 1 to 6, right? So for instance, from 1 to 3, right, we have 2 links. So we check it here and we see how we have 2 links, F and I. If we go to the second row, it is the same, but for the node number 2. If we go to the third row, it is the same, but for node number 3. Right? For instance, 3 has 2 links with linking it to 4. So if we go to 3, 4, right? 1, 2, 3, 1, 2, 3, 4. Right? We see how we counted 2 links here. So it's not very difficult to calculate. Anyway, if you have any doubt, please let me know in the comments. I hope you enjoy it.